In the demo lab, Lonnie's prepared liquid oxygen, liquid nitrogen, and a strong magnet. He's going to pour liquid nitrogen across the poles of this magnet. Now, liquid nitrogen, based on our molecular orbital theory, is diamagnetic. All the electrons are paired. No unpaired electrons in N2, the molecule, means that the N2 molecules are not attracted to the poles of a magnet. They're diamagnetic. Let's watch that one more time. Nitrogen passes right through the poles of a magnet. Essentially, all that's happening is the magnet's being cooled by the contact with the liquid nitrogen. Liquid nitrogen, nitrogen molecules, diamagnetic, based on our prediction from molecular orbital theory. Now here's liquid oxygen. Liquid oxygen has a pair of unpaired electrons, 2 unpaired electrons in pi star molecular orbitals, and you can see those unpaired electrons impart a magnetic nature on oxygen molecules. Oxygen molecules are attracted to a magnet. And in liquid form, you can see dramatically that effect. The oxygen molecules, with their 2 unpaired electrons, attracted strongly to the poles of a magnet. That's a dramatic demonstration of the power of molecular orbital theory, predicting oxygen, the molecule, O2, has a pair of unpaired electrons and is paramagnetic. Oxygen molecules attracted to the poles of a magnet.